Okay, students, so let us start our discussion on the KVPY mock test paper 2, solution to the questions. As I, told you, all these questions are available in the online test platform. Here is the result, and let's see how we can, understand all these questions one by one. Uh, so the first question is that what is the remainder when 5 power 87 is divided by 15? So to answer this one, so let us go back to our number theory. Is that so? Let us we need to divide by 15. So the way we can do is that let's make it. We observe the following. We observe the following. So here your target should be to divide 5 power 87 by 15. So if you make 5 power 87 divided by 15, so that will be what? That will be 5 power 87 divided by 15. We can write 5 into 3. That is equal to 5 power 86 divided by 3. Because we have cancelled that 5. 5 we have cancelled, so 5 power 87 become 5 power 87 minus 1, which is 5 power 86. Now here we need to understand one important point is that let us first understand that when 5 power 86 is divided by 3, what will be the remainder? Sorry. Let us first find, okay, let us first find the remainder when 5 power 86 is divided by 3. And for that we need to take the assistance of binomial theorem. How? 5 power 86 we can write is that 5 we can write it is 6 minus 1 power 86. Correct. Now in earlier classes we discussed about the binomial theorem. What is binomial theorem? If I go back to the theory quickly, so binomial theorem, it looks like something like that. If you have a plus b power n, so that we can express as nc0 into a power 0 into b power n minus 0 plus nc1 into a power 1 into b power n minus 1 plus nc2 into a power 2 into b power n minus 2 plus in that way it will continue, and finally you will get ncn into a power n into b power n minus n. Now if we apply this theory here in the 6 minus 1 power 86, so how we will get it? Let us find it out. Okay. So let me write it here so that we can expand properly. 5 power 86. So let me write it here. So we write like this. So 5 power 86, that is equal to 5 is equal to 6 minus 1 power 86. 6 minus 1 power 86. 6 minus 1 power 86 is equal to, we can write that 86 C0 into 6 power 0 into 1 power 86 minus 0 plus 86 C1 into 6 power 1 into 86 power, sorry, 1 power into 1 power 86 minus 1. By the way, here one thing will happen. It is not exactly 1. It has to be minus 1. Sorry. It has to be minus 1. So here also it will be minus 1 power. And then what will become 86C2 into 6 power 2 into minus 1 power 86 minus 2. In that way it will continue, and finally you will get 86C86 into 6 power 86 into 1 power, minus 1 power 86 minus 86. Now look at this thing very minutely. So if you look into this thing, this comes what? 86 is 0. By the way, I hope you are all aware of that, permutation and combinations, the fundamental theorem. What is NCR? Okay, NCR is equal to n factorial divided by r factorial into n minus r factorial. So that concept we can apply here, and if we apply this in this formula, we will get 86 is equal to 86 factorial divided by 0 factorial into 86 minus 0 factorial into 6 power 0. 6 power 0 is 1 into minus 1 power 86 is what? It is actually 1. Minus 1 power 86, 86 is even number, that is why it is 1. After that, what will happen here? You see, in this term there is a 6 power 1 is there, we can take 6 common. Here 6 power 2 is there, you can take 6 common. In that next term also there will be 6. So in that way, all these terms, if you see, in all these terms you can take 6 common. You can take 6 common. So if you take 6 common here, then what you will get here? You will get all the terms here. But we are not bothered about all these terms, because our main purpose is that what will be the remainder when we divide 5 power 86 by 3. So obviously, if we divide something, a 6 multiplied by something, and if it is divided by 3, the remainder will be 0. So we are not bothered about this thing. So what will be our main concentration? Here will be 86. So it is here 86 power factorial divided by 86 factorial into 1 into 1 plus 6 into the term, whatever the term is. So for there we get what? 86 factorial by 86 factorial is 1. So it is 1 plus 6 into that term. That means what? If we divide it 5 power 86 divided by 5 power 86 by 3, remainder will be what? Remainder will be 1. So that shows when 5 power 86 is divided by 3, remainder is 1. As we have now the point is that we have cancelled the common factor. What we did, the that common factor 5, we need to revert it back. So we have cancelled the common factor 5, so that 5 has to be reverted back, correct? So as we need to revert back this 5, you remember here we have cancelled that 5, here we cancel that 5. So this this thing has to be this 5, this has to be reverted back. And if I use a different color, it will be more clear to understand. So this 5 and this 5 here we get cancelled. No, that's why you get 5 power 86. So that 5 has to be reverted back when finding the remainder of division of 5 power 86 by 15. So the remainder will be 1 into 5. Okay, so if I write very clearly so that you can make it, because I will share all this material with you now. So if I write very clearly here, so as we have, so I'm writing it here so that you can, later you can follow all these things. So as we have cancelled, as we have cancelled as we have cancelled common factor 5, we need to revert it back. We need to revert it back when finding the remainder of division of 5 power 87 by 15. 5 power 87 by 15. Okay, and the remainder is and the 1 into 5, that is equal to 5. So as we get this thing, so we get the correct option as B. So we get the correct option as B. So please have a look into it. So now you understand that why I always say that you please do it by your own. So that you can really enjoy the way I have done, and if you have any statement to make, you can make it. So here one statement, so very interesting, that you may have this doubt, though we have not asked it, but proactively let me bring this point, that why I have multiplied 5. So if you see in this problem, the number 5 and 15 are not co-prime numbers. Hence, the procedure is to cancel common factor 5, find remainder, then multiply the remainder by common factor 5. So whenever you have this kind of problem, you need to apply this concept when they are not co-prime numbers. Here 5 and 15 are not co-prime number. Hence, the steps are, the procedure are is that to cancel the common factor 5 first. After cancelling the common factor 5, find the remainder. Whatever the remainder you will get, then you multiply that common factor with that remainder. In this case, the remainder was 1 and common factor was 5. So to get the to get that remainder, we need to multiply that common factor 5 with the remainder. What we get is 1. That is 1 into 5. That's why it is 5. I hope you get this point clearly. So we can now go to the
Sir,
yeah, please.
sir, I didn't understand the permutation combination.
Okay, so thing is that we can discuss on this now. So what is okay, what is permutation and what is combination? So let me explain a little bit about it. Okay, then we can have later some classes and we can have a very detailed discussion on that. Okay, so let me tell you what is permutation and what is combination. So here it is. Permutation is something when you are arranging some objects, and combination is something when you are selecting objects. Okay, suppose you have been given n objects, n distinct objects. There are n distinct objects given to you, and you are taking R objects. So then take R objects, and this R is obviously less than equal to n. Now if you need to make that permutation, that means arrangement. Permutation is related to arrangement, and combination related to selection. Let me help you understand this thing by means of an example. And here it is. Suppose there are, let me explain you here. Suppose there are 3 balls. Okay, the balls are on 3 different color. Blue, so there is a blue ball. Okay, then there is a black ball, so this is a black ball, and there is a green ball, so this is a green ball. Okay, so if I say, so this is a blue ball, this is black. So if I write it this thing, so now what I'm asking is that suppose out of these 3 balls, if I take 2 balls and arrange, okay, so suppose I give it that blue ball is 1, that black ball is 2, and green ball is 3. Suppose out of these 3 balls you are taking 2 balls and you are arranging it, then how you can arrange? So here is the arrangement. So what is the arrangement here? We can arrange, you can take 1A, 1 and 2, then you take 2 and 1. Okay, so arrangement of, I can write 2 balls out of these 3 balls. What will be the arrangement? Let's find it out. It can be 1 2 2 1, then it could be 1 3. Okay, let me write in the 1 3 3 1, or it could be 2 3 and 3 2. So how many ways? If you look into this thing, this is in 6 ways. Okay, now if we look into that, selection of 2 balls out of these 3 balls, selection of 2 balls out of these 3 balls, how we get? Here it is a way to, we can take 1 2, or you can take 1 3, or you can take 2 3. We are selecting, we are not arranging, we are not make the 1 first and then 2, or 2 first and then 1. Only 1 and 2. Okay, then that is sufficient to for selection. So how many ways? it is in 3 ways. Now the point is that the problem becomes, more challenging to compute like this in a brute force method, is that if I say there are 100 balls and you need to take 32 balls, in how many ways you can arrange, then it will take enormous amount of time, okay, to compute that one. For that, there is a formula. For arrangement, the formula is that NPR. That means it is called P stands for permutation. So this stands for NPR means, if I write here, NPR means, okay, arrangement of R distinct objects taken from n distinct objects. Okay, so that is NPR. But for selection, what we do is that it is called NCR. Okay, means selection of R distinct objects, taken from n distinct objects. So for NPR, what is the formula for NPR? Let me use a different color. Yeah, for NPR, the formula is something like this. NPR is equal to factorial n divided by factorial n minus r. And for NCR, the formula is factorial n divided by factorial r into factorial n minus r. So now let's see in our example, the example what we used a few minutes back. So what was the example? Example was that something like that, out of 3 distinct balls, because the balls are distinct. One is blue, one is black, one is green. Okay. So then here in this case n is equal to what? N is equal to 3. And what is r? You are taking 2 balls. So then it is NP2. Sorry, it is 3p2. 3p2, that is equal to 3 factorial divided by 3 minus 2 factorial. So 3 factorial is equal to what? 3 into 2 into 1. I hope you are aware of factorial. And 3 minus 2 is 1. 1 factorial is 1. So 3 into 2, that is equal to 6. These are the 6 ways. 1 2 is the one way, then 2 1, then 1 3, then 3 1, then 2 3, then 3 2. Now let's see here in case of combination. Here also n is equal to 3. Out of 3 distinct objects, you are taking 2 objects at a time. Then it is 3c2. So that is equal to 3 factorial divided by 2 factorial into 3 minus 2 factorial. So what it is coming? It is coming as, sorry. So factorial. So this is equal to 3 factorial is that 3 into 2 factorial divided by 2 factorial. 3 into 2, 1 factorial is 1. These 2 factorial get cancelled. That is the 3. That's why we get 3 na. 1 2 is one selection, 1 3 is another selection, and 2 3 is another selection. There is 3 ways. But in case of permutation, we get 6 ways. There is a beautiful relationship between the permutation and combination. How it is? You see NCR, what we wrote about NCR? NCR is equal to n factorial divided by r factorial into n minus r factorial. So from here what we can write? We can write NCR is equal to 1 by r factorial into, you see, n factorial divided by r factorial into n minus r factorial. So this implies what? This implies NCR is equal to 1 by r factorial into, it is NPR. I'm sorry, there is a small mistake I have done here. So let me remove this one. It's a typo. So this is not required. Okay, so if I write very clearly, so it will be something like this. I hope you will face some problem in looking into it, because there's some software update is happening in Microsoft side. So please allow me a couple of minutes till that update happens. Yeah, it is coming back. So it has come. So now let us discuss this thing. So so what we can write here is that, so I made a mistake here, as I said, you know, so as we make 1 by, so it will be like this. So n factorial by n minus r factorial. So anyway, here it will be NCR. So what is coming? 1 by r factorial into NPR. So that means what we can say, that NPR is equal to r factorial times into NCR. So the number of permutations of r distinct objects from n distinct objects is equal to the r factorial times of selection of r distinct objects taken from n distinct objects. Okay, so now I discussed the very fundamental and very beginning of permutation and combination. There are a lot of special cases, there are a lot of corner cases, there are a lot of other challenging formulas that we'll discuss as time uh, goes by, but this is the fundamentals about the permutation and combination. So I hope it is clear. The student who is a Pratik, clear it is now?
Yes, sir.
Okay, so now please have a look into this one so that we can go to the next question. So let's look into the next question then.
Sir, but I didn't understand how did 0 factorial into 86 minus 0 factorial became 86 factorial.
Oh, okay. So you are talking about, okay, let me discuss about this thing. Thanks for asking the question. So let me explain you this thing. Okay. So I really appreciate, see, questions are very good. Always ask questions. So you are telling us that how come, I can do it in the here. You are telling that how come, tell me here, 86 factorial divided by,
86, 86 factorial by 0 factorial into 86 minus 0 factorial.
how come it become 1, right?
86, yeah. How did it become 86 factorial by 86 factorial?
Yeah. So now tell me, see, you know what is factorial? Factorial n is equal to n into n minus 1 into n minus 2, and in that way till it goes to 3 into 2 into 1. That is the definition of n factorial. With
Yeah.
basic condition is factorial of 0 is equal to 1 and factorial of 1 is also equal to 1. Correct.
How is that, sir?
This is a definition. This is the definition of factorial.
Okay.
This is the
Okay.
definition. Okay. Okay. If I ask you that, okay, how come if you divide something by 0 is undefined? This is the way the definition of division, isn't it? Correct. So
Okay.
here is the definition of factorial. So then what it happens? It happens is the 86 factorial. 0 factorial is 1 and 86 minus 0 is 86. Na? So this is 86
Mhm.
factorial. So that is why it is becoming 1.
Okay.
Okay. So now let's go to the next question. Our next question, if you look into that, online platform, is that it is mentioned. So let me, bring that question. Sorry. So here is the question. Uh, if x minus 6 is the remainder when x cube, you please go through the question by your own. X cube minus 2x square plus 5, plus px minus q uh, is divided by x square minus 2x minus 3, then what is the value of p plus q? So, let us discuss together about this, problem. So, if you look into this one, uh, x cube minus 2x square plus px minus q, this is a polynomial of degree, 3, isn't it? So, it is a polynomial of degree 3. And it is divided by what? X square minus 2x minus 3, which is a polynomial of degree 2. And remainder is x minus 6. That means what? That means, you know, the quotient must be a polynomial of degree 1. Okay, if we write this thing in a, in the form of Euclid's division lemma, it will be something like this: x cube minus 2x square plus px minus q. So this is, multiplied by something that will come. What is that something? X square minus 2x minus 3 and plus remainder is x minus 6. That means here it will be definitely a linear, equation. This part has to be a linear, otherwise how it can be x cube? If it is not linear, it cannot be a constant, then there will be no x cube. And if it is more than x, that means if it is x square, it will become x4, which is not there in the left hand side. So it has to be a linear one. That quotient has to be linear one. So let's assume that quotient be x minus a. So if we assume this thing, and then it becomes an identity. So if you look into this one, this becomes an identity. What is the difference between identity and equation for your information. Identity is something which is true for any values of x, but whereas equation is that it actually true for some fixed values of x. So as it is an identity, so let us expand. So if we expand, then what we'll get, we'll get something like this. In the left hand side, as it is x cube minus 2x square plus px minus q is equal to, in the right hand side, if you expand, you will get equal to x cube, so x cube, then minus 2x square minus ax square plus 2ax plus 3a plus x minus 6. So this implies, what? So if we make it in a more, proper form, x cube minus 2x square plus px minus cube is equal to x cube minus of a plus 2 into x square plus 2a plus 1 into x plus 3a minus 6. So now in this case what will happen is that, you see, this is an identity, so the coefficient of x square in the left hand side, which is minus 2, should be equal to the coefficient of the x square in the right hand side, which is minus of ax plus 2. So what we can write, that minus 2 is equal to minus of a plus 2. Coefficient of x in the left hand side, which is p, should be equal to the coefficient of x in the right hand side, which is 2a plus 1. So then what we can write? We can write p is equal to 2a plus 1. Correct? Now the constant term, which is minus q in the left hand side, should be equal to 3a plus constant term in the right hand side, which is 3a minus 6. So what we can say is that minus q. So these are the equations relationship we are able to establish. This is another one, and then minus q equal to 3a minus 6. So now if you solve these things, so what is the value of a you will get? Value of a you will get is equal to 0. The moment of value of a is equal to 0, the value of p become 2 into 0 plus 1, that is 1. Sorry, here I think p 2a minus 2, I think I made a mistake here somewhere. Sorry, it is 2a minus 2 here it will be. I made a small mistake here, so just in this place it is coefficient of x in the right hand side, it is 2a, and here it is minus 2, so 2a minus 2, so it will be 2a minus 2 here. P is equal to 2a minus 2. Rest is fine. So we get it here 2a, it is minus 2. It is 2a minus 2. So then what we get? P is equal to, minus 2, because, sorry, 2a minus 2. So it is, 2 into, let me use the eraser once more time. So a is equal to 0. So then it is 2 into 0 minus 2, and minus q is equal to 3 into 0 minus 6. So from here what we get? We get a is equal to 0, p is equal to minus 2, and q is equal to 6. q is equal to 6. So what is the value of p plus q then? So p plus q is equal to 6 minus 2 is equal to 4. So we get the correct option as C. I hope you understood now. Any doubt, please do let me know. Just have a look into it, and if you have any doubt, please do let me know. Okay, if things are clear, then we can go to the next question. The next question, uh, if you look into this, so let's look into the next question. Let me clip it here first. Question 3. So the question here is that PQRS is a parallelogram such that PQ is equal to 10 units. The altitude corresponding to the sides PQ and PS are 7 units and 8 units respectively. What is the value of PS? Let us first visualize this problem. Okay, so first let's draw that parallelogram. So this is the parallelogram PQ RS. So it is given PQ is equal to 10. So it is given PQ is equal to 10, and the altitude corresponding to PQ and PS. That means this is given, this is the altitude, this is given as, suppose this is L. Then what we get is that SL is equal to 7, and if you draw a perpendicular from here to here, suppose if we consider this as M, then QM, that is also given as 8. What we need to find? We need to find the value of PS. So that is the question. Apparently it looks like that how to approach, this is a fundamental question, though, from our knowledge of our, previous, class, in class 9th or 10th standard. But KVPY is all about, asking those fundamental questions and how you are going to apply to solve it. So how to do this thing? So let's see. So let us assume that PS is equal to X. So let PS is equal to X, and we need to find the X. What is the area of the parallelogram? Area of the parallelogram. So area of the parallelogram PQRS is equal to, there are two ways you can calculate the this area of this parallelogram. So here it is. One way, what we can find it out, this is what is the area of a parallelogram? Base into altitude. So we can write this is equal to PQ into SL. Also we can think in the other way, this is equal to PS into MQ. Correct? I hope you agree to me. So that means these two quantities are equal. What is PQ? PQ is equal to 10 into what is SL? SL is equal to 7. That is equal to PS. PS is X, which which we are going to find. X into QM. QM is equal to 8. So now we can simplify it further. 4, 2, 4 and 2, it is 5. Sorry, it is 5. So this implies what we get, X is equal to 35 divided by 4, and if you write in the mixed fraction it will be 8 3 by 4 square units, units. So we get the correct option as A. So we get the correct option as A. So this is the correct option we are getting. Okay. So I hope,
Sir,
yeah, please.
sir, are you indirectly using the property of similarity?
No, we are not using the property of similarity. We are using the area of parallelogram into different forms.
Because SLP and QMP are similar.
SL,
SLP and QMP are similar, no, sir?
SLP and QMP. Yeah, but
MP.
yeah, if we use, yeah, in that approach, with using that one also you can find the answer, but that will take some time. Why you need to use similarity? Because the moment it is SMP, then how you can find PM and how you can find PL, SLP? Think in this direction. Okay.
Okay.
Correct, correct doesn't mean that it is the, a direct approaches, give the solution. Okay. So it has to be correct and it has to be also optimized. And now you can ask the smart question here is that, sir, how you can think of that when you use the area of the parallelogram? That is the question that, where you should think of. Because you see that there are two altitudes given. The moment parallelogram, two altitudes given, you need to find the sides of the parallelogram. Always think about that, how you can use the area of the parallelogram into different versions. Because two altitudes given, that's why you can use the, two ways, because we know the area of the parallelogram is equal to base into altitude. As two altitudes are given, so we can use the two bases. If you look into this one, first base what we use is PQ, isn't it? So if you look into this one, so the first base what we use is like this, PQ is the base. The moment we are using PQ is the base, then we are using that SL as the altitude. Now another altitude is also given. Which altitude is given? QM. Okay, the MQ altitude is given. So then we can use the other side of the parallelogram, that is PS, which we need to find. So this should be the approach. This is the way, in order to formulate that, answer. So that is why my always suggestion is that practice, and this kind of online test platform would makes, very, very rock solid preparation. Okay, so any doubt, please do let me know before we proceed to the next question. Okay, I think we can discuss one more question. So better to discuss. Uh, okay, so let's look into the next question. So the next question is, let me cut paste from that, our main online platform. This is a very classical question. Okay, so and we should discuss one day in details in some special class I will take. and I'll discuss about this one, this question, that cube, and how to color the different portions of the cube. Okay. So here is the question. Let me now question 4. So here is the question. A solid cube made out of wood is having 5 centimeter as the length of each of the sides. The entire surface of the cube is painted in deep green color. If the cube is cut into 125 number of equal cubes by making 4 cuts in each axis, the number of cubes with exactly 3 faces painted is what? So now cube and the coloring of its different faces we can discuss in a more details in a separate class. But one thing I can tell you is that this is one of the very classical problem, and you should be very well thorough about it. So I'd like to discuss something with you before giving this one. Think about that, the cube, and visualize. Let me bring you know one figure here, so that just give me a second. So the problem what we are discussing, it is something like this. Let me share this screen with you. So I hope you are able to view the screen. So let me make it narrow a little bit. Yeah. So look at here. So this question is related to this, that if you have you know a solid cube made out of that wood is having 5 centimeter length of each sides, the entire surface of the cube is painted in deep green color. Okay, here it is red. By just to give you an example, if the cube is cut into 125 equal number of cubes by marking 4 cuts in each axis, the number of cubes with exactly 3 faces painted is. So how to approach this problem is that cubes and its painting. So you see when three side painted is that whatever the red color what you see. So it is irrespective of the number of cubes you make out of it, the answer is always equal to 8. Okay, because there are only you will get the corner cubes which are such that all the three sides are painted. So now what, as I was telling in the beginning of to discuss this problem, so here 8 is the correct option. Okay, now it may possible to have the same question is molded like that. How many cubes are there with three sides, sorry, two sides painted? How many cubes are there, all the four sides painted? How many cubes are there? There is no side painted. Okay, how many cubes are there? Only two sides painted. For that, there are different formulas and to concept. So today we do not have time. We already, it is 10:30. So we'll discuss in some other day about this thing in details. So now, before I, conclude for today's session, my humble suggestion is that please appear for rest of the questions. We discussed four questions today. Please appear the rest of the questions, and we'll have our next discussion on Wednesday. Not only that, we can have session before that also at individual level. Okay, so as I always suggest that please be engaged with me. Whenever you have some problem, please discuss with me. Whenever you solve these things, if you have in doubt, please send me on WhatsApp. Okay, I make sure that I'll get back to you in within 24 hours. Okay, so with this, I conclude the our class today. We'll have another class on Wednesday, the same time at 9 o'clock. Okay, thank you very much. Yeah, thank you, Pallavi. Thank you. Uh, okay, we'll thank you very much. We'll have our next class on Wednesday. Thank you, Pratik. Thank you, Pallavi. Thank you, Vaishnavi. Thank you, thank you. Thank you, Akanksha. Thank you very much. Thank you, Urvi. Thank you very much.